Good afternoon, everyone. Namaste. I hope you all had tea and you're awake. My presentation would be a bit more boring because it's generally text. I don't have too many pictures, unlike all the rest of the speakers, because this is more on electrical and fire safety. So just to start with the presentation, this presentation more on design approach. But when we talk of electrical and fire safety, it is more on design, proper maintenance, and proper upkeep of the system design in terms of load balancing and everything. So when you're designing an electrical building, you have to know what type of building you're designing, what is the requirement, because with each type of building, like residential, commercial, industrial, in industrial also, what kind of building it is. It is very essential to know what is the kind of the building, what is the behavior of electrical load, and what is the load requirement for the equipment, for the lighting, and for the air conditioning and accessories. So you should know what is the type of building. It is very essential. You cannot assume that if a building is designed for residential, be converted to a hospital or to a hotel, and it will function properly. At least the electrical systems and the rest of the systems have to be undone and then redone. So we have to understand how the system behaves in different type of buildings. We should not always say that, okay, electrical is not being designed properly or operated properly, that's why there is a fire in the building. Both go a lot hand in hand. Electrical and fire, they can be very good friends and they can be very bad friends for the building and amongst themselves also. So whenever we are designing a building, we should always keep in mind what can be the future load. So if you look at the life of a building or life of electrical equipment, it is almost 20-25 years for an electrical system and maybe 100 years plus for a building. So we have to see that if I'm designing a building for 25 years for the electrical system, for the next upcoming 25 years, the technology of the systems is going to change, the watt per square feet requirement is going to change. So my high side system of the electrical system should be designed in a way that it's able to sustain the load without undersizing the equipment for the next 25 years. Because if you look at way back in 25 years, your load requirement for buildings was very less. Now it is going on increasing, though equipments are becoming more efficient. But still, your electrical requirement is increasing. So when we design a building, when any designer designs a building, they have to take care of expansion requirements and also redundancy. Redundancy in terms of when we talk about fire systems, when we talk about fire pumps or elevators, or there are certain essential systems in a building which should keep on operating, whether the other systems are operating or not. So in that case, we should be sure that the systems have redundancy in the system. It should not so happen that the wire got broke, so the elevator is not working, or the fire pump is not working, or the evacuation system is not working. So there was a list of systems which Sandeep had displayed in the morning slides, which we have listed in our National Building Code of India also, that these are the systems which are no-go systems. We cannot afford them not to work. Those have to work. So for those systems, and if it's a data center, then obviously essential loads, you have to list out all essential and non-essential loads when you're designing a building, and design proper redundancy for those systems. Right sizing of the equipment. There are a lot of times when we estimate that there will be a load maybe for 3 transformers or 2 transformers, and we install only 1 transformer, that okay, whenever the load increases, the room will be occupied. But what happens if I don't size the equipment rightly, or the client does not install it rightly? The space which is available in the substation or the DG room or the chiller plant room or the pump room, people will start using that as a storage occupancy. Should equipment be equipment space be used as a storage? That is the question you should ask yourself whenever you are leaving such spaces. So size it rightly. Don't oversize it, don't undersize it. But provide the room sizes according to the equipment you have sized. Do not assume that if in future I need to increase the substation size, the DG side, I should not be requiring to change the room size. Take the room as is required. Don't oversize. Otherwise, you will, after 10 years or 5 years of operation, you'll see a lot of unwanted material being stored in that space. Planning. When we talk of planning of equipment, there are different sectors in a building. Like if you talk about the property we are standing in, this property will have a chiller plant room, will have a hot water generator, will have a electrical substation, a DG room, and a lot of scattered load, like banquet hall has a load, rooms have a load. Banquet hall rooms will have minimal load, but major bulk load, you should all keep it near the substation so that you're reducing the cable lengths, and also that is reducing further on the fire risk. So whenever you're designing your systems, design is optimized, and also if it's optimized, the risk of fire will be less. So there are certain kind of things which, let me know when it is boring, because I don't want people to sleep in the room. Right? Okay. So whenever we are sizing any equipment, whether it's electrical or fire or HVAC or anything, we should always think how the equipment is going to reach the room where it is to be located. Or if in case it has to be replaced, how will you replace it? It should not be broken down into pieces and then brought into the property. And exit is not a problem, because exit you can take it in parts. But the new equipment should be brought in a single module for its performance, best performance. If it's, when assembling, if it's left loose, then obviously there'll be problems, and then there will be a fire, slowly. So next is systems crossing in electrical rooms. Like this is a quite luxurious hotel, but we have seen certain hotels in India and outside the India also, where the electrical room is also used as a maid's room. Or electrical room and DG room are same, or electrical and chiller plant room are same. Though these are systems which coexist in a building, they should not coexist in the same room. Can you imagine an electrical room with storage in it? Towel storage, stacking, everything. So slowly these kind of things have a repercussion, and in case there is a leakage in electrical system, there is a fire which bubbles up in the room, then you have fire material into the room. What will happen is a disaster. Your 2 or 5 rated door also may not be able to contain the fire in that case, because you've put the fire and the material into the same closet. So there's certain things which we have to take care. And even during operations, you should not think that, okay, I missed making a maid's room, so let me use the electrical room or the HVAC room as a combination of maid's room. Or any cluttering of the rooms which are there for services. There are times when you forget that there was a water closet above the electrical room. And how the pipe of the water closet will cross? It will come into the electrical room and cross into the adjacent. So what is it? It's water above the electrical panel. Is it a good design? It is not a good design. And the day water leaks into the panel, then the fireman will come and say that there was a fire because of electricity. It was not because of the electrical system or electricity. It was because of the bad maintenance of the property and also of the bad design. So we have to take care of all these things when we design or operate these buildings. So next point also I have covered. So electrical distribution amongst fire compartment. Like Sandeep was talking about fire compartments, and if there is a fire in one compartment, the other compartment should keep on working safely so that it can be used also as an assembly point of the people who are evacuating from the fire zone. So what all things you have to think about when you're doing those kind of things as far as services are concerned. So you have to ensure that the electrical supply, the light supply, the air conditioning are not mixing up in the compartments. I will not say plumbing, fire, pipes and all that, because that really does not make a difference. But the air conditioning and the electrical systems have to be segregated between the two compartments, so they don't carry the fire into the next compartment. Then equipment sizing, rating of the compartment. So when we are, suppose we are having a 1000 kilowatt load and we size it for either 800 kilowatt, it's underrated, or we design it for 1500 kilowatt, it is high rated. What will happen in case there is a short circuit in the system? This higher rated will not trip and will cause a fire in the system. If it's underrated, then the minute it reaches 800 kilowatt or goes beyond, the system will trip, indicating that there is something wrong in the system, but it is still not performing. So what will you do? You will isolate the circuit breaker which is tripping. Then again, it will cause fire because your systems are not designed right. How you can monitor these systems, how you can control these situations? By monitoring and by controlling it, by monitoring it, that how many amps are going through the circuit breaker, how much current is flowing through the circuit breaker. There are now fault monitors also, which can tell you what is the leakage current in the earthing system or in the neutral cable. So you can say whenever there is a level is going up beyond the safer limit, you can always check your design, you can always check your system where the leakage is happening. Control it before the fire happens. There are systems which are not to be bypassed, which a lot of times we bypass because of continuity of service at that particular time, which can cause fire. So as my previous speaker was talking about maintenance audit. Maintenance and audit in electrical system, in fire systems, HVAC systems, in all the systems is very, very essential. Because if you don't maintain it properly, you don't audit how the system was designed and how it is performing, systems will not work. They are not automated. They need maintenance. They need approach. You need to service your circuit breakers. You need to check the connections, whether the cable is becoming loose. You have to tighten up. You have to control the systems. You have to see if there is any additional load on the system, whether it is overloading the circuit breaker. If it is overloading the circuit breaker or the cable is heating up, you have to handle it before it goes beyond control and it leads to a fire. So there are a lot of things which we have to do during the maintenance of the system, during the upkeep of the system. There is always a life of a human or of a equipment. So whenever we are towards the end of life, like when we say that, okay, a person is 80 years old or 85 years old, he is going towards the end of his life. So you need more maintenance and you have to disengage him from certain things so that rest of the systems keep on working. Same is there with the circuit breakers. So when the circuit breaker is nearing the complete wear and tear of its controllers, so we have to replace the circuit breaker before the system collapses. So these are maintenance, and you have to take care of these things. You have to monitor them and take care, replace them before they cause the damage to the system. There are certain things which we need to put on emergency system, like fire alarm, emergency lighting. So electricity had gone in the morning in this hall. So what was the thing which you noted? That there was very few lights which were switching on. So during the design of the system, they would have designed at least 10% of these lights to remain on UPS, so that there is a safety in the hall. Even though it is largely occupied, people should not feel scared. They should not start moving around in case the electricity is not there. Emergency switches, the lights should always be on. So lights, emergency lights, fire alarm system, evacuation system, ventilation system, there's so many things which have to remain on even during emergency. It should not so happen that somebody just came, switched off the entire system, and nothing is working. So there are set of systems you have to design parallelly so that they keep on getting electricity even though somebody is trying to switch off. In that case, what can you do as a designer or as an operator? You can color code it. You cannot replicate your mind into the person who's operating it or who's going to come in time of emergency. So color code the panels, color code the systems so that they know that this is the color which should be always on. Like sir was talking about security system. So in case somebody switches off the main supply, should the security system be on or off? Can somebody answer? Nobody wants to answer? Security system should be on always or no? Fire system? Electricity, lighting? Depends on the type of light. You have to segregate. You have to compartment, like which type of light should be on and which can be on, off. Elevators, on or off? Off. In case it's a complex building. In case, suppose sir was talking about Heathrow Airport. So elevator should be on or off? So there will be a set of elevators which may be used for emergency. If the elevators are being used for emergency evacuation or for emergency purpose for general normal operations also, so those elevators should be on. Escalators. Nepal off. Good to go. Fire pump room. Fire pump room, it's a fire conference. Plumbing plant room. Now this is a tricky question. Plumbing plant room. Partially on, partially off. The sump pumps should always be on. Can somebody answer why sump pumps will be off or on? Why on or why off? Sump pumps. The pumps which are used to take out the water from the basements or from the plant rooms. Why? Somebody can give the mic to the person who's answering? That person raised his hand. There.
In emergency cases, to fire the fight, the pump must be on, I think.
Sump pump.
Yeah. That which is connected with the emergency supply system, that should be on.
So if it's a sprinkle building and the fire is in the basement and water is filling up, so you have to take out the water. So that's why it should be on. Or if it's raining also simultaneously and water is coming inside, so it should be always on. So think why on or why off, you'll never forget the answer. Codes do specify something, but you have to change the system according to your requirement, your building requirement, your system requirements.
I think for this emergency response, I think there must be 2 or 3 alternatives for the electric supply, direct from the electric supply and from the alternatives way also. And for alternatives, I think it must be on all the time and it must be observed by the security personnel. Thank
Pardon, I
you.
couldn't get you the last line.
Sorry.
I could not hear the last line clearly.
I mean to say that if this system is for the emergency support, and that system should be on, but it must be monitored by the some designated person all the time.
See, it's very difficult to monitor all the panels all the time by a dedicated person. Because if I tell you you have to stand here for 24 hours, I'll pay you. Will you be able to stand?
Uh, uh, Person can be
There,
changed.
there BMS, AI, everything comes into picture.
This is
Because
a,
machine can do that job which humans sometimes cannot, because humans will lose focus. Humans cannot be that focused 24 by 7 on an activity. It becomes monotonous. And when things become monotonous, then you lose your focus.
sure.
That's why monitoring, not by humans, but by machines, and then by humans is very essential. Once the level goes up beyond, when it's a red signal, then it will give you alarm, you'll go through the history and you'll say, okay, this flag is up, I need to control it. It has to be a mix of machine and human. Otherwise, we'll be just putting some man and we are relying on that person's brain and attention to work.
So CCTV works all the time with the people.
CCTV works in capturing. You have to put some logic behind it that it should take care of the picture when there is some movement or there is some activity, and then also give you the feedback. Same happens with electrical systems also, or any other system.
Thank you, ma'am.
So latest somebody was talking about EV systems, EV cars. A lot of them in Nepal, in India, and all over the world. But how do we take care of thermal runaway of a battery? And in case there is a fire in one EV car, how do we control it? Any idea, any feedback on that? How do you do it in Nepal? How do you control it? These cars right now are very new in the country, maybe 2 years, 4 years old. They have not reached the situation when they will start misbehaving because of loose wiring, because of some mishap, something. But we all together have to find a solution to it and isolate it before it becomes a disaster. We should not wait for the disaster to come and then find a solution. This is something which, at least I don't have a solution. We have been discussing it over the panels, that what is the solution in case there is a EV fire and it's located in a basement along with so many petrol or diesel vehicles. What will happen? Disaster will happen. पानी दे दो, यहाँ से दे दो. This is something we should look at and talk about. Presently, whenever I have to, as a project engineer, sometimes locate EV vehicles, I always tell them, locate it in open area. On podiums, at least they are naturally ventilated. So that even if there's a disaster, all the smoke is not coming into a room. But best, till we don't find a solution, we should locate it all in the open. Somebody is there? Yes, there behind. Please raise your hand. so that they can locate. Your mic has to be switched on.
Check.
Yeah.
Sprinkle system, one of the solution for charging. So when we are charging EV, there sprinkle around 65 degrees Celsius, there automatically sprinkle start. So
Okay,
maybe they.
let's have a discussion on this. Where is the EV battery located?
Actually, I don't know.
So a battery of a vehicle is located in the base of it. So this detector or the sprinkler will not even get the heat out of it before it bursts. The battery will start flashing.
I think you are talking
need
about.
You need to submerge the battery into water continuously to take control of the battery, which is not visible in most of the locations, unless until you locate all the batteries in a pool.
I think you are talking about before any disaster happenings. I'm talking after disaster. If there is any certain accidents happens, then only we can be these systems will be work.
So actually, we should do a preventive check before, like where to locate, how to control, before the actual disaster happens on EVs. Amongst petrol cars, because there are all possibilities that the petrol cars will catch fire and then the situation may be bad. There are controllers in the charger, there are controllers in the car which will trip the system in case they detect the thermal runoff. But with time, there are all possibilities of them malfunctioning. When they malfunction, the disaster may happen. And sprinkler will sprinkle it, but not enough to control the battery fire. Need of the hour is commitment from all. Not only from me, for you, but everybody, right from the person who's taking care of the plant, to the person who's monitoring, to the person who's designing, and the person who is expanding the systems. Because once a building is done, then suddenly the occupant comes, I wanted another room, I wanted another premise, I wanted this, I wanted that, and then the system starts over-utilizing and possibilities of error. So we all have to consciously take that commitment that we should build up redundancy in the system, whichever system it may be. And when we are expanding, we have to check whether the breakers or the HUs or the systems, whichever is going to cater to the new establishment, is sized for it. Thank you.